Hello, hello, hello. What's up to you all, matriculants? Welcome to it. This is Learn Extra, your favorite show. We missed you guys so much. I hope you enjoyed your holidays. Well, for some, it wasn't really a holiday. It was a work in progress also towards their marks, great marks. And I hope you performed very well on your mathematics. I'd like to hear from you guys on the page. How did you guys perform on your mathematics? But my name is Abram. If you're joining us for the first time, I'm with Tamerlane. Tamerlane, how are you?
Hi, Abram. I'm well, and you?
I'm good, thanks. How were your holidays? If you had any.
To be honest, I haven't had my holiday just yet, but I'm really looking forward to it.
Like every teacher didn't have a holiday, eh?
Yeah, in fact, no. Even during the holidays, we work. So
Well, that's nice because you're helping our nation, building our nation educationally. Well, what are we doing today?
So, considering it's prelim time for our matrics, we're having a good look at some revision. And we've kind of taken a couple of questions out of both paper 1 and paper 2. Tried to focus on sort of important areas, sequences and series, functions, and a bit of trig from paper 2.
Right, nice one. And guys, as I said, if you want to learn more and learn extra with us, all you need to do is to join us on facebook.com/learn extra. Also on Twitter, follow us at learn extra. Remember what Benjamin Franklin once said, that you tell me I forget, teach me, I may remember, but if you involve me even more, I will learn better. So guys, we'd like to involve you guys and #work together. So go on Facebook, that's where you'll also find your links. On those links, there's a test yourself question link, whereby if you fill those answers correctly and you are amongst the first people that fill them correctly, you stand a chance of winning this awesome Casio calculator, proudly sponsored by Casio. The competition is closing next week, Monday at 8 a.m. So get entering right now. Lastly, we do have a Nokia mobile mathematics app, whereby when you go to More Maths, which is momaths.org, using the code which is I2IK, as a matriculant, you can answer some of those questions, challenge yourself and challenge other mindsetters, rank yourself and see where you belong and how's your understanding on what we've been doing. And never hesitate, if you have some questions, we're here to help you guys. Over to you, Tamerlane.
Fantastic. Right, grade 12, so we're not going to waste any time. We're going to get straight into it. As we said, we're doing some revision for your prelims and mid-year exams, so let's see what we are going to be having a look at today. Okay, so basically just quickly saying we are revising both paper 1 and paper 2 today. And before we get stuck into all of that revision, I thought let's just kick it off with a bit of a challenge question for you guys. So typically what you find, and this is probably a question that would come up in paper 1. As part of question 1, generally speaking, you're going to have a question which just tests your knowledge of algebra, so exponents and equations, and what do we do with a question like this, okay? It's one of those ones that's a little bit out of the ordinary, so you need to think a little bit out of the box here, okay? Always remember to apply your basic rules. Any of these questions always goes back to your fundamental basics, but you need to think a little bit out of the box here. So take it down, have a look at it while we're on our breaks, and I'd be very keen to see if you actually managed to get it right, okay? All right, we had 4 to the x times by 6 to the y, which is equal to 48 to the 12. So what I'm hoping you recognize is the exponential equation format here. And they've asked us to find the value of x plus y and obviously show all your working out. So there we go, that's your challenge question. We're going to take a quick look at your summary, all right? What I've done for you on your summary is I'm not going to spend too much time going over it now because it is something you guys can go onto the website and have a look at. But what I want to point out to you is that I've taken your formula sheet, okay, the one that you get in your exam, and I've broken it down into the various sections, okay? So obviously you have your formula sheets in front of you, but it's important to know which formulas belong to which sections. So please go into the website and have a look at your summary over here. As you can see, for example, how I've just taken, we've kind of cut out the formulas that apply just to sequences and series, and what I'd like you to do is become really familiar with what belongs where and what formulas you would use where. Your formula sheet is certainly there as a help, but don't use it there as an absolute reliance, that you have an absolute reliance on it. So it's there to assist you. You know, at a glance, you'd be able to look at it and say, oh yeah, that's the formula that I need, and off you go. So just go and practice that and have a careful look at all of those, okay? All right, guys, I'm going to get straight into it, and I'm going to take some questions from paper 1 to start off with, and just a bit of practice from sequences and series, okay? So what do we know? Sequences and series, we have arithmetic sequences and series, we've got geometric sequences and series. you've got your SN formulas, you've got your TN formulas, we've got sigma. There's a lot going on in this section over here. But let's also not forget that there's also grade 11 revision that you mustn't forget about, okay? And this question over here actually focuses on that. And in fact, if you were just watching the grade 11 show prior to this, there was a very similar question, so maybe you just will remember it. Okay, so let's see what we've got over here. We've got 1, 3, and 5 are the first 3 terms of the first differences of a quadratic sequence, okay? Now, remember from grade 11, just remember your definition, your quadratic sequences is where you have got a second common difference. You remember that? So when you take your first term minus your second term minus your first term, third term minus your second term, and you do that pyramid going down, you find that the second difference is actually your common one, making it quadratic. Just to remind you, remember the standard formula for your quadratic sequences, Tn equals an squared plus bn plus c. Okay, so remember, we don't teach you this in grade 12 anymore because we've taught it to you in grade 11, and the point is don't forget it, okay, because obviously just because we haven't incorporated it in the grade 12 syllabus, it may very well still come up in your exam, okay? All that grade 11 work is still there. Right, now the wording here is really important, guys. 1, 3, and 5 are the first 3 terms of the first differences. Okay, so what we need to understand is this. We've got the first term, second term, third term, fourth term, and so on of a quadratic sequence. And when I took the first differences, the first 3 terms we said was 1, 3, and 5. So 1, 3, and 5 are the first differences of your quadratic sequence. And then they go on to say that the 7th term is actually 35. Okay, so if I were to carry on here, I've got a 5th term, I've got a 6th term, but when I get to my 7th term, I know that the value of that term is 35. Okay, so with that information, what they're asking us to now do is to determine the 6th and the 5th terms. So we're looking for the 5th and the 6th terms in that sequence over there. Okay, well, let's just play with this a little bit. Let's have a look at what patterns we're developing here. I've got a first difference of 1, 3, 5. If I were to continue that, obviously we're going up in jumps of 2. So we've got a 7, we're going to have a 9, we're going to have an 11, all right? So if I were to work backwards in the sequence, well, if my 7th term is 35, and I had to add 11 onto that to get to term 6, working backwards, we're just going to subtract, okay? So 35 minus 10 would be 25, minus another one would be 24. So we can say that term 6 is going to be 24. So let's do this. Let's erase it. Let's take it out of here now. And let's fill it in as 24. I'm going to do it in green so we know that's a value that we've actually filled in now. And to get to our 5th term, we're going to do the same thing. 24 minus, okay, I'm just going to minus 10, which makes it 14, plus an extra 1 is going to be 15. So let's take that out and let's replace that with 15. So now we've got a 5th term, so term 5 was 15. Okay. Okay, so now we've got this 6th and 5th term. What else do they want to know from me? The next thing they're asking us to determine is the nth term of the quadratic sequence. So remember, with any sequence, it's all very well to have the numbers, but what really helps us is if we have it in terms of its general form, in terms of its general formula, because that is when you can work out anything about the sequence, okay? All right, so let's go here. We know we had a 7th term, which was 35. We had a 6th term, which was 24. We've got a 5th term, which we said was 15. Let's just go back to this page quickly. We've got our working out. Let's finish off this sequence over here, and let's work out the other terms. So I'm going to work out the rest of these values over here. All right. 15 take away 7, that's going to leave us with 8. 8 take away 5 is going to leave us with 3. 3 take away 3 is 0, and 0 minus 1 is going to be minus 1. So that's our sequence, okay? So now that we've got that, let's see if we can work out what our general term is going to be. Okay, I'm just going to remove that so I've got some space to work. first difference, we had a 1, 3, 5, 7, 9. If we do our second difference, we're going to land up with a 2. We're going to land up with a 2 and land up with a 2. And remember, that's your defining characteristic of your quadratic number patterns, is that you've got your second common difference. All right, so doing a very similar method to what was being done in the previous lesson, the grade 11 lesson, is we take this little stacked set of numbers over here, and to work out the general term, we start by doing this. We put a 2a in front of the first term of your second common difference, okay? You're going to put a 3a plus b in front of the first number of your first common differences. And then on your top, you're going to have an a plus b plus c equals, and you make it equal to the first term of your actual number pattern. Okay. And this is how this method works. It's really quite nifty, because now what we say is this: 2a equals 2, which means that a is equal to 1. All right. Now, if a is equal to 1, that means that I've got 3, but instead of a, I'm going to say 1 plus b equals, and we make it equal to the first term over there, which is 1. So b is then going to be equal to, if I subtract 3 on the other side, we get negative 2, which means that a, which I know is 1, plus b, which I know is negative 2, plus c equals, and we make it equal to that first term of negative 1. And what does that give me? I've got 1 minus 2, which is minus 1. And if I plus 1 on the other side, I get 0. Okay? So into my general term of an squared plus bn plus c, we have got the general formula as follows. A was 1 n squared. B we knew was negative 2. So sorry, it's not actually a positive, it's a negative 2. Okay, so n squared minus 2n, and the c is 0. You can fill it in, but obviously it's not going to make any difference, so I'm actually just going to leave it. I'm not going to fill the 0 in for your c. That's the general term of your sequence. From there, we can work out whatever it is that we need to know about that pattern over there. All right. So guys, just a quick reminder, your grade 11 theory is as important as your grade 12 theory, and as far as number pattern goes, don't forget to learn those quadratic number patterns, okay? Okie dokes. Another important question which often comes up as part of your sequences and series questions is sigma, all right? So let's have a look at an example like this one over here, and let's remember what sigma is all about. Okay, first things first, your symbol sigma is your symbol that represents the sum of, okay? So as soon as we're working with a sigma sum, we know we are working with our SN formulas. That's our sum of formulas. The only thing we don't know at this stage is, are we working with a geometric series or are we working with an arithmetic series? We don't know that yet, okay? So this is a great starting point for sigma. With sigma, the first thing I want you to do is this. I want you to work out what term 1 is, what term 2 is, and what term 3 is of your sequence, okay? Obviously, once you know what your first, your second, and your third terms are, you can start establishing whether it's arithmetic or whether it's geometric, and what your A is, what your first term is, and whether you have a D, a common difference, or an R, which is your common ratio, okay? So how do we work out term 1? We start with k equals 1, and we substitute into our general equation. So 2 times by 3, I'm substituting 1 minus 1, which is going to give me 0. 2 times by 3. Now what we do now is, remember, we substitute consecutive numbers after the 1. So you would substitute 1, then you would substitute 2, then you would substitute 3, okay? So I've got 1, I would then say 2 minus 1, which is 1, and 3 minus 1, which is 2. That's giving me 2, that's giving me 6, that's giving me 18. Okay, so what can I now see? Now I've solved a whole lot of problems for myself, because I can see that my first term is 2, okay? And I can see by the nature of the sequence that it's not arithmetic, it's geometric. And I'm multiplying by 3 each time to get to my next term. So your common ratio is 3. Okay, so great. Now we know that it's geometric, and we know those two terms over there, all right? Please remember to calculate the n, the number of terms that you are adding up in your sequence, all right? We always take the term at the top minus the value at the bottom plus 1. Please remember that. So in this case, it would be what's at the top, which in this case is just n, minus 1 plus 1, okay? So in this particular case, obviously the minus 1 and the plus 1 cancel out. So the number of terms that we're adding up in your sigma sum here is exactly that value for n over there. But I do just want to point out to you, so please watch out for this, guys. Let me just quickly put an example up here. Let's just say, for instance, we're adding up 10 terms. I'm going to give it, let's use the same equation. But let's say over here I've got k equals 3, okay? Please remember, grade 12s, that once you've established, you would find your first term by substituting 3 into the value for k. Then you would find the next term by substituting 4, and then the next term by substituting 5. So you do it as consecutive terms, all right? That will give you first term, second term, third term, all right? To calculate the number of terms that you are adding up in the sequence, you take your 10 minus your 3, which is 7, plus 1, which is 8. So the number of terms, the n, that you would substitute into your SN formula in this case would be 8. It would not be 10. Okay? So please, guys, watch out for that. Your big clue there is when you do not have a 1, when that's anything other than 1, all right? You've got to watch out for your top minus your bottom plus 1, all right? So that's just quickly throwing that in the side just so you don't forget that. But let's finish this one off over here. So we know it's geometric, and the geometric SN formula is as follows. We've got A, we've got R to the n minus 1 over R minus 1. They've told us that the sum of my terms is 550, what have we got? It's 531,440, which is equal to A, which we know is 2, R to the power of n minus 1 over R, which is 3 minus 1, which is 2. So I'm just going to write that as 2 over there. Okay, this is actually going to work nicely for me because my 2's will cancel. Minus 1, instead of having minus 1 on the right-hand side, I'm going to bring it over to add. So therefore, I'll have 531,441 equals R to the n. Sorry, R, we do know R, being silly here. R was your rate is 3. So we've got R, 3 to the n. And if I've got 531, let's see over here, to the power of n, can we 531,441, if we prime factorize it, it should work out to be 12. Let me see what I've done over here again. So I'm rushing this now, so let's see. Where's my eraser? Give me a sec, let's just quickly try that again. Okay, so we had A, which was 2. Just 2, huh? Yeah. Common ratio, which is 3 to the n minus 1 over 3 minus 1, which is 2. Those cancel. That comes over to give us 1, which is equal to 3. Okay, sorry. We have to use logs, okay? So log of 531,441 equals n log 3. Okay, a bit of log revision over there. We add log to both sides, and the n comes over to the front of your log. And I would have log of 531,441. I'm going to divide it by log 3. That's going to be equal to n. And let's use our calculator. We've got fraction. We've got log. We've got 531,441. Let's just close that bracket. Over log 3. There we go. So we get our 12. All right, guys, so just also a bit of revision there that logs can come into it. If you're solving an exponential equation where your bases are not the same, you need to remember your laws of logs. Okay, lots to revise. All right, I think we're probably due for a quick short break.
Yes, we are. And during this short break, Mindsetters, you still have the challenge question. And also go to momats.org. Your code is I2IK. We'll see you after this break. Welcome back, Mindsetters. Now on the page, if you just joined us now, there's a question that I've popped to you guys. How did you write your June exam? And there's so many comments that you guys are giving us and feedback. We'll we'll share some later, Tamlin. They're so interesting. I'm sure that you could also offer some advices to other mindsetters who didn't write very well.
Yeah, unfortunately, some of those comments are not the most positive, particularly with paper 2.
No.
Guys, you know what? The only way that you can honestly get this right is to sit yourself down with that calculator, pen and paper, and to fill the book with practice. Don't lie on your bed flicking through a book thinking that you know what's going on, because I promise you that's the wrong way to do it. You need to sit there and really push and grind away at just practicing yourself. Your mind has got to work through those questions, and it's got to actually go through the process. So reading a textbook is not studying maths. Definitely. You've got to sit there and practice it yourself.
So true. Before I tell you guys about the competition that we have, there's a quick shout out for you, Tamlin. It's from Sibusiso Gabriel. It says, "Oh wow, Tams, Avi, please tell the teacher she really blesses me when she's teaching. Thanks, keep it up."
Ah, that's awesome. Thank you.
Thank you so much, Sibusiso. And now, exciting news, we have this awesome competition. It is a water game competition, a serious game competition, which is all about raising awareness on saving water and how we can keep our communities a safe environment, not just misusing our natural resource, which is water. So it's an awesome game, and if you take part and win, these are some of the prizes that you can stand a chance of winning. We've got first prize, which is 5,000 Rand.
Wow, everyone could do with a bit of that.
Yeah, second prize 3,000 Rand, and the third prize is 2,000 Rand. But it doesn't end there. I should elaborate more. There are some other prizes, such as over 20,000 worth of cell phone airtime to be won as you play the game.
Wow.
And a weekend trip for 4
Sure, guys, that's worth playing
to the game
for.
reserves. To a game reserve anywhere in South Africa. So that's so awesome,
Fantastic,
guys.
yeah.
And lastly, there's a Samsung Galaxy Tablet 3, which will be a lucky draw for the players who complete the game. So guys, all you need to do is to jump to watergame.co.za, and also on Facebook and Twitter, #SAWatergame. It's so exciting, guys. Share with your friends, and let's see if you can play and learn at the same time.
Cool. Well, that sounds great. Okay, guys, the next question, still sticking with paper 1, I'm going to have a look at a functions question. I like this question because it deals with a couple of funny things that I think a couple of you do have problems with, so let's have a look at it. We have got a diagram with 2 functions. We've got a y equals g of x, which is equal to your log function. Okay, so you've got your log function. And y equals h of x, which is equal to negative x minus 3 squared minus 1. That's your parabola, okay? Guys, I cannot emphasize enough to you how knowing your formulas is crucially important to understanding this section. Just by looking at it, we should be able to establish that your turning point is positive 3, negative 1, which in fact you can see from there, okay? It's in your diagram. So you've got a negative parabola. How do I know that? Because that's a minus over there, all right? How would I work out x-intercepts of either one of your graphs? I would let y equal 0. How would I work out the y-intercept? I'd let x equal 0. Okay, so these are all things that we've got to be so familiar with functions, so that we don't get stuck on the little details of functions and we can actually interpret the graph properly, okay? Okay. So what we have is these 2 functions, and we're told that they both pass through the point P, which is 3 and negative 1. First things first, they're asking us for the value of A, all right? So just to point out that A is on your g of x graph of log base a to the x. So we're sitting with g of x equals log base a to the x, okay? Best thing about graphs is that if you've got a coordinate point that is sitting on your line, if in doubt, take that point as long as it's sitting on the line and sub it into your equation for your x and your y. So I've got an x coordinate of 3 and I've got a y coordinate of negative 1. So sub them in. Negative 1 equals log base a, and that's going to be to the 3. How am I going to solve for a? We're going to take it from log form and we're going to convert it to exponential form, all right? Exponential form means we take the base of a, we put it to the power of negative 1, and we make it equal to 3, all right? Now, obviously, we want the a to be on its own, so basically I get rid of that negative 1 by raising it to negative 1 on both sides, leaving us with a equals 3 to the negative 1, which is actually a third. Okay, So what's the equation of my log function? G of x is equal to log base a third x. Okay, cool. So now we've got that equation over there. What's the next thing they want from us? Now they want the equation of g to the negative 1x, okay? Notation, what does that mean? What are they actually asking for when they ask for that g to the negative 1x? They're asking for your inverse graph, okay? When it's the inverse graph, it is always the reflection about the line y equals x. So reflects about y equals x, okay? And remember the trick with that, when you're reflecting your graph about the line y equals x, we take our x and our y and we swap them, okay? That's what we have to do with it. So we know at the moment that we've got an equation of y is equal to log base a third x, okay? So to get our g to the negative 1 of x equation, so that's supposed to be a dot dot, dot dot, okay, we are going to start by swapping our x and our y values. So therefore I'm going to say x is equal to log base a third y. Once you've done that, please don't forget that you're not done. You need to make y the subject of your equation. So you need to take that and changing it to exponential form, you're going to change it to y equals base a third to the power of x. Okay? So what have we landed up with? We have a log function, all right? We inverted it. We converted it about the line y equals x. Remember, the line y equals x is this line over here. Okay? And what we landed up with was an exponential function, which would probably look like so. Okay? So we've landed up with this exponential function over here. Now that we've got that, that's the equation of g to the negative 1. What else do they want from me? They're wanting the values of x. So we're looking for the x values for which 1 is less than or equal to g to the negative 1 of x, which is less than or equal to 3. Okay? So let's just be clear about this over here. Remember that g to the x is basically the y values of your function where x is the variable, okay? So g of x is your y value, all right? So g to the negative 1 of x is the y value of your inverse functions, all right? So this is basically what this question is saying. What are the values for x where the y values are from 1 to 3 on your inverse equation, all right? So we don't actually have to use the diagram for this. We can actually use points. We know with a log function, we know that the x-intercept is going to be the coordinates of 1 and 0, all right? And we know that it's got the points of p, which is 3 and negative 1. So that's the original log function. Now, do you agree that g to the negative 1 would pass through? Remember, if we do the inverse, we have to swap the x and the y around, which means that your g to the negative 1 of x is going to pass through the coordinates of 0 and 1. So all I've done is I've swapped the x and the y coordinates around, as well as the point negative 1 and 3. Okay? So look here. They wanted to know the x values between where the y values are 1 and 3. Well, if the y values are 1 and 3, then the x values are going to be 0 and negative 1, all right? So for what values of x will the y values be 1 and 3? My x would be, I'm going to write it as interval notation, from 0 to negative 1. And I'm using square brackets because it is included. Another way of writing it, we could say 0 is less than or equal to x, which is less than or equal to negative 1. So it's kind of actually not quite a domain and range, but it's looking at the y values and the related x values to those points. Okay, so quite a nice question, just understanding the notation. What are they actually asking you for there? And it's so important that you understand that. Once you understand what they're asking, it actually is quite simple, the working out. Okay. Now they're wanting us to determine, now this is a very interesting question, a possible restriction that could be placed on h of x. Now remember, h of x is this one over here. That's your original parabola to ensure that h to the negative 1 of x is a function. Okay. So, we will have to place a restriction. So we have to stop it at certain points, the original one, so that the inverse will be a function. Okay, now first of all, let's say this. What's a function? All right, remember a function is where every x value has only one y value. Okay, so it's a 1-to-1. So if I were to draw a dotted line through any point on this parabola, the normal h of x, can you see it's only ever crossing through the function at one point? So what I'm illustrating there is that it is a function, it's 1-to-1, okay? Now, if I were to draw the inverse of this function, all right, if I were to swap all the x and the y values around and I were to sketch it, 3 and 1 would be -1 and 3, so that's going to be about there, okay? And it actually lands up looking, it's a graph that does that, okay? So that's the inverse. Now the question says, what do I have to do to this function, all right, to make sure that, what I have to do to this one to make sure that this one is a function? Look over here, guys. If I draw a vertical line through this inverse graph, can you see that's crossing at 2 points, okay? Which means it's not a function because it's not 1-to-1, all right? So in order to restrict it, do you guys agree with me that if I were to get rid of the bottom half of that function over there, then it would be 1-to-1. Then I wouldn't have a problem. It would be a function, wouldn't it? Or what if I did this? If I had the bottom part, what if I erased the top part? If I got rid of that part, then what I would be left with is a function, okay? So, all right, so we're getting an understanding of what it is that we're actually trying to get to over here. So we know that we need to either get rid of the top half or the bottom half of your graph in order to make it a function. But that means, what do I have to restrict on the original graph? Because the question said the restriction on your h of x to make sure that only the top or the bottom would be applicable. Well, if I were to remember that the x value at this point over here is at 3. So if I just use my hand and I cover that up over here, okay, if you're having a look over here, cover that up. If I took my x values that are only greater than 3, all right, then, so I've got a nice squiggle here which shouldn't be there, then do you agree that this side wouldn't exist anymore, and that would mean that when it reflected, it would only be the top half of the graph, all right? Or what if I just covered up this half, if I got rid of this half, and I only kept that half, which meant that my x values were all less than 3. Then what I would be left with is only the bottom half of the graph, okay? So what's the restriction? What's the answer that we're actually looking for here? In order for this to become a function on as an inverse graph, we're going to have to restrict it so that your x values are either greater than or equal to 3. So if I eliminated that side of the graph, or if I said x was less than or equal to 3, so in other words, if I eliminated that side of the graph and I'd only be left with the one side. So by restricting it as x is only bigger than 3 or x is only less than 3, we would either get a top or a bottom of the inverse, making it a function. Go and have a look at that again. I know that that's sometimes a difficult concept to understand. So go and have a look at it. Just try and make sure that you understand what it is that I've done over there to make this become a function and not just a relation as it is over there. Okay. All right. I know it's a little bit tricky. Alrighty, do we have another question here? Yes, we do. Now they want to know the values of x for which g of x times by h of x is less than 0. I'm sure you guys recognize this question because it comes up in just about every single functions question. Okay, so let's think about this. G of x is the y values of your log function. H of x are the y values of your parabola. Alright, now I want to take the y values of the log times by the y values of the parabola, and it has to be less than 0. So if I'm multiplying two values together, the only way I'm going to get the answer less than 0 is if I'm multiplying a positive times a negative, okay? So let's look at the log graph. If I look at these y values, do you agree that all of these y values are all positive? Up until that point over there, because now we go below the x-axis and those y values are just going to continue infinitely being negative. Okay? Now let's look at the parabola. These y values are all negative. There's no positive y values here whatsoever. Okay? So now we've got to take the combination of the two. So what I'm going to do is I'm going to look horizontally across the x-axis over here. And from where my y-axis is equal to 0, I've got positive y values over there, and I've got negative y values over there, and it goes up until that point. Okay? They're positive, and they are negative, and a positive times a negative is going to give you negative. Okay? From that point onwards, those are all negative, and these are all negative, and so a negative times negative is not going to give you less than 0. So the only portion of this graph where the g of x times the h of x is going to be less than 0 is where from 0, but remember it didn't ever touch 0, so where x is less than, but where it's not including 0, up to this point over here, which we know is the x-intercept of your log graph, which is going to be 1. So therefore, what's our answer? X is an element. We're going to say a round bracket from 0 up to 1. And because it just said less than, it didn't say less than or equal to, we keep it a round bracket. Okay. All right, so there we go.
Right on time. I think it's time for a short break.
Okay, perfect.
Right, well, my is during this break, you've got the last chance for you to do the challenge question, because after the break, we'll be tackling the challenge question. However, if you're still confused anyway, send us your questions. We'll still give you the answers after the break. Welcome back, Matrix. Now, for those of you who are following us on Winter School, and for those of you that weren't, I just want to tell you that we've been running a competition which was proudly sponsored by Intel, whereby we gave away an Intel tablet. Such an awesome gadget to have, and you missed out, unfortunately. But however, we do have a winner, and congratulations to our winner that won during the Winter School. However, my entities, I just want to urge you guys to go and register on the Intel application, which is available for you guys. It is the Explore and Learn application. Let's beat all the other countries, and as South Africa, let's register in numbers and let's learn, explore, and learn. Remember, we do have our mindset content available on the Explore and Learn application. More details will be on facebook.com/learnextra. Back to you, Tamlin.
Thank you. Guys, in our previous lesson with the grade 11s, one of our mindsetters wrote in and asked a question saying, why are we going back over stuff that we've done earlier in the year? Am I right, Abram? That was the question. What are we doing? Why are we going back over this? You need to really understand, guys, that going back and constantly revising and constantly building your understanding is the key to understanding and actually succeeding in maths. Maths is not, it's not all isolated little sections where the one is not influenced by the other. So constantly going back and constantly revising is just laying a more solid understanding for what it is that we're going on to learn again. And in terms of your exams, it's crucial, guys, that you go back over your exams and you get your scripts from your teachers and you look at what it is that you did wrong so that you learn from those mistakes. Because if you don't learn from those mistakes, well then, what was the point of writing the paper in the first place? So that's why you really need to understand the value at least, in revising and going back over everything. That's crucial. Okay, so make sure you do. All right, we're quickly going to have a look at the challenge question. Let's see if anybody managed to get us an answer.
Yeah, there are some answers, but I think if you could give me your answer, I'll tell you who got the right one.
Okay, so this is where we should start with this. We should take 4 and we should break it up into 2 squared, and it'll be to the power of x. Then we've got 6. 6 is going to be 3 times by 2. That's to the power of y. 48, okay, 48, let's just prime factorize that quickly. If you don't know this function on your calculator, it's quite a nice handy one, the prime factor button, 2 to the power of 4 times by 3. So 2 to the power of 4 times by 3, and that's to the power of 12. Okay, so step number 1, I hope that was your first step, putting you on the right path. So now we're going to have this. We've got 2 to the 2x times by, I've got 3 to the y, I've got 2 to the y. I have got 2 to the 4 times 12, which is 48, and we've got 3 to the 12. Okay, so right, now what do? Do you guys agree we need to do a little bit of tidying up here? Let's take all the bases of 2. I've got a base of 2 here, I've got a base of 2 here, I've got a base of 2 here, okay? So that's going to be 2 to the power. Remember the rule, when you're multiplying bases, you add your exponents. So I've got 2 to the x plus y. Remember that on this side over here, to bring it over to the left-hand side, I would have to divide it, okay? Because the opposite of divide is times. And when you're dividing bases, you subtract your exponents. So that's going to end up being a minus 48 over there, okay? And let's do it on this side. I've got 3 to the 12. And instead of having a 3 to the y on the right, on the left-hand side here, I would divide it on the right-hand side. And when you divide bases, you subtract your exponents. Okay, so I'm guessing up to now you probably got something like that. I'm guessing up to this point you were actually okay. This is where we had to start thinking a little bit out of the box, okay? Typically, what I would do with this is I'd probably introduce logs. Okay, because my bases are not the same. Okay, we've all been taught that. If your bases are not the same, put a log in front of each side. But it's not really going to help you so much in this case because of these variables that you've got here. You've got variables of x and of y. It's causing problems for us. Okay, so let's do a little bit of investigating over here. Let's say, for instance, I had 2 to the x times by 3 to the y, which was equal to, I'm just using an example here, 3 to the 2, let's say, okay? If 2 to the x times 3 to the y was equal to 2 to the 4 times 3 to the 2, then do you guys see the correlation that the x value would then be equal to 4 and the y value would be equal to 2? Okay, so I'm using that as the basis of my understanding here and thinking, okay, well, if that holds true, then what I need to do is I need to have a 2 on both the left and the right-hand side, and I need to have a 3 on both the left and the right-hand side, okay? Which poses a little bit of a challenge. So this is what I'm going to do. If I were to multiply the left-hand side and the right-hand side by 1, timesing something by 1 doesn't change its value, all right? And in exponential terms, something to the power of 1, something that's 1 is anything to the power of 0. So I'm going to make that a 3 to the 0 times by 2 to the 2x plus y minus 48. And I've got 3 to the 12 minus y. And I'm going to make that 2 to the 0. Okay? Which means that if I follow
right,
the...
Tamlin,
Yes.
we've run out of time,
Oh, no.
unfortunately. We only have got 10 seconds.
Oh dear. Okay, well, it's x plus y equals 30, if our memory serves me correctly.
Unfortunately, thank you so much, man. We love you and peace.